Hey everyone, welcome back. So today I'm releasing a preview version of localGPT. This is an opinionated implementation of a retrieval augmented generation. And this new version is actually going to be more of a framework where you can use this version to implement better retrieval system and play around with different hyperparameters. So if you're not familiar with localGPT, it's my own open source project that lets you chat with your documents using local models. So everything is private. You're not using any external APIs or sending your document anywhere. Now, to give you a sense, this is the interface of this new version, which is a lot more cleaner compared to the previous iteration. Now, in this video, I'm going to first show you a number of different features, both for the indexing and retrieval. And then later in the video, I'll show you the number of different options that are available for you to install this on your local machine. Keep in mind, I have been testing and developing this on Mac OS. So there might be some bugs here and there if you're running this on Windows or Linux. So when you load the new version of localGPT, you're going to see this screen. The first option is you can create a new index. Second is you can select an existing index. So I have a number of different indices already created here. And the third one is that you can use this version of localGPT to directly chat with local model. Now this is powered by Ollama. So it's going to pick all the LLMs that are available on Ollama. And then you can just select one of them and start interacting with it. Now for the first message is usually, since it's pulling up the model from Ollama, so it's going to be probably the longest time, but later on the speed improves. Okay. Now going back, let me walk you through some of the options that are available when you're creating an index. So let's go here. Here I think I have a number of different invoices that I created. So let's just select a couple of these. For the purpose of this demo, let's call it invoice data v2. Now there are a number of options for retrieval. So you can use dense embeddings along with full text search. So I highly recommend to just select hybrid. There is also implementation for late chunking. By default, it's not enabled. And my recommendation would be to create multiple different indices of your file using these different options, and then run a number of different questions through those to figure out which combination works best for your solution or your problem, right? So I'm not going to enable those. There's high recall chunking. So this is basically sentence level chunking. Now you're going to get much more accurate chunks, but the indexing process itself is going to take a while, right? Now, when you start using this version of localGPT, you're going to see that the indexing is usually a lot slower compared to some of the other solutions out there. And the reason is because of these different options. Now, we can select different embedding models. Current embeddings models that you see here are going to be available by default. Now, for the first time, if you run this, it's going to locally download those models. The other ones at the end that you see, these are hosted through Ollama. So if you have an embedding model that you're running on Ollama, it will be able to pull those as well. So I'm going to just select this. Now I'm going to give you a quick overview. There are going to be, I think, a couple of more videos where we're going to discuss the technical details. But for every document, I randomly choose a few chunks and then create these overviews for those documents. I'm going to show you a triage step in which the model will automatically decide whether to use its own knowledge, chat history, or go and retrieve documents from your index. So for that, we need to create these overviews. And then there is contextual retrieval. This is an approach very similar to what Anthropic recommends, but instead of looking at the whole document, I just look at 5 chunks around a given chunk, create a small summary of it, right? So it preserves local context. So every chunk is not just isolated or independent, but there is a lot more context around it. Now for these two options, I'm using a relatively small 0.6 billion model because these are going to be compute intensive tasks. So once you have this set up, just click on start indexing and it's going to index. Here's the backend processing that is happening. All the options that we selected. Now here it created the initial embeddings, or actually loaded those. Once an index is created, it's going to automatically create a new chat for you. Now, if you click on the index, it's going to show you all the hyperparameters that you chose, right? So that's why I recommend to create multiple indices, at least for the test data, with different hyperparameters, different settings, and then you can run a few questions and see which one does well. Now, to show you a few retrieval examples, let's look at another index. So this index has the DeepSeek V3 paper along with the O3 mini system card. So in total, we are looking at around 90 to 100 pages in total. Now, if you click on this, so here are the two files that are within the index. I did not use the high recall chunking or sentence level chunking because we're going to end up with a lot of different chunks. Now, the rest of the options are very similar to what we saw before. So if you go to settings, you can actually customize your retrieval pipeline as well. So you can set different options and toggle them. So for example, for complex questions, it's going to decompose them. Now, even for decomposition, you can either use an LLM to generate answers for each of those sub-questions, or you can just retrieve all of the chunks and then feed those directly to the last LLM to generate answers, right? So you can play around with those hyperparameters as well. In terms of search type, there's hybrid search. Right now, that's the default one. And again, for LLMs, by default, I'm using a Qwen 3 8 billion model, but you can essentially use any of the models that are available on Ollama. Now, the performance is really dependent on the LLM that you decide to use. But for this demo purposes, and since a lot of people are going to have either 12 or 16 gigabytes of VRAM, I just wanted to keep an 8 billion model as a default model. Okay, we're going to go through these different settings while we are experimenting. So let's say initially I say hi, right? It's a very general question. So it just uses the LLM directly to generate a response. Now, the Qwen models, they are thinking models. So even for a simple question like this, it will end up using some thinking tokens. If you ask general questions, in most of the cases, it's not going to trigger the retrieval or RAG pipeline. There are some failure cases in which it doesn't do that, and that comes down to the model itself. But in the background, what essentially is happening is that it looks at those document overviews that we created, and for each question, it asks the LLM whether those document summaries create information relevant to this question or not. So if it finds there is relevant information, it's going to trigger the RAG part. And if it doesn't find relevant information in those documents, then it's going to just use the LLM knowledge. Now, if we ask something like, what are these documents about? There is a scenario in which it might look at the document overviews, but in this case, I think it decided to just go and retrieve some chunks. And you can see for the questions in which it decides to use the RAG pipeline, it goes through a number of different steps. So first, it figures out whether to use the RAG pipeline or not. Then it will generate subqueries, retrieve context, re-rank those, then expand context windows around those chunks, generate answers for subqueries. Now, if it's a single question, it just directly goes and generate the answer. So it says these documents primarily focus on the evaluation, risk management, and technical capabilities of AI models, particularly in the context of safety, performance, application-specific tasks. I think it picked up some chunks from the O3 mini paper. So it gives you a pretty good overview, right? And here are the different chunks that it ended up using. Now you will notice the formatting is a bit off. This is something I still need to fix. That's a small bug that needs to be addressed, right? And that's why I'm calling it a preview version. It's not going to be on the main branch, but I'll show you the specific branch for this new version. Now, by default, you are going to also see a confidence score with the answers. So essentially what is happening is it generates the final answer, then it takes the context, the question, and sends this final answer to another LLM call to grade this, right? So you can disable that because that in itself is going to easily take 5 to 10 seconds depending on the complexity of the question. But in the settings, if you go, you can just easily disable this verify answer, and then you're not going to see that verification step. Now, since we were talking about DeepSeek V3 and O3 mini, so let's ask a question which is actually relevant to those. So let's say, what is the total training cost of DeepSeek v3 model. Okay, now hopefully it's going to go through the RAG or retrieval pipeline. It's generating the answer, so let's wait for it. And by default, I'm using the Qwen 3.8 billion model, which is a reasoning or thinking model. So that's why you see the reasoning being streamed first, and then you're going to see the final answer. Now, you can easily replace this with a non-reasoning model, but the prompts themselves might need some work for that in that case. All right, so here it says the total training cost of DeepSeek v3 is explicitly stated as 5.57 million USD. And then it goes through how many GPUs were used for pre-training. And these are the different chunks that are being used. Now, since we use that context or contextual retrieval, which I think probably more appropriate name is going to be context enhancement. So with each of the chunk, it's going to add the summary, which is based on all the running window around the chunk. So right now the running window is about 5 chunks. Okay, now let's ask a question related to 3. So let's see if we can find some interesting questions. Okay, so this section talks about contextual nuclear knowledge. Actually, okay, let's see. So there is a set of 222 multiple choice questions. Let's actually ask this. How many multiple choice questions were used to test the nuclear knowledge of O3 model? Let's see what happens. Okay, so again, it created that sub question. All right, okay, generated the final answer here. The thinking token, when it's streaming, sometimes the formatting is a bit off. So that's still something that needs to be addressed. But here are the thinking tokens. Now, this is the total context that was used. I think it's not showing all 512 tokens in each of the chunks. So that's something I need to look at. But if you look at the answer, it says the context explicitly states 222 multiple choice questions that were used to test nuclear knowledge in evaluation of models. Specifically, the context mentions. So here is, I think, a snippet from the context, right? So you can see it is actually pretty accurate when it's able to find those proper chunks in the context. Now, by default, if you look here, it's going to initially retrieve 20 chunks. Then if we use a re-ranker, it's going to rank 10 chunks, or it will pick top 10 chunks out of those 20. And if you enable this context window, it's going to expand it further, right? My recommendation is initially start with 10, but then bring it down to something like 4 or 5, right? And see if you get the similar level of performance or not. Now, one problem is that in order to speed up things, I am using a cache for the question answer pair, right? So let's say if we were to ask the same question again, let me actually see if I can. So just to show you an example, if I use the exactly same question, then it's going to just go and pick the cache answer, right? So sometimes you'll have to tweak with the question if you don't get the answer that you're looking for. And normally it helps a lot if you just put something like according to this document, right? So then that's a signal to the system to use the RAG pipeline rather than trying to answer things from its own knowledge. Okay, I'll show you one more capability. So let's say if we ask something like, what are the total number of training parameters in DeepSeek v3 and O3 mini models? Okay, let's send this question. Now, this is a relatively complex question. So if you try to do retrieval on this, you're going to run into issues. But here you can see that it divided this into 2 sub questions. And now it's streaming answers for the intermediate questions that it generated, right? So you're going to see sometimes it stream things simultaneously, which is, I think, a very neat effect. All right, so we got the final answer in here. It says DeepSeek v3, the total number of training parameters are 561 billion. This is explicitly stated in the context. Okay, and then for O3 mini, the total number of training parameters is not mentioned in the provided context. The snippet focuses on performance, metrics, benchmarks, and evaluation. So this is actually correct because we don't know what the size of O3 mini is. But then you can even go to look at the individual answers that the system tried to create. I think they tried to answer one of the question twice. Okay, so this is interesting. Yeah, I think probably there is something wrong with the streaming. So I'll need to address that. And that's why I'm saying it's a preview version, so it's not fully flashed out. And I highly recommend to test it out and tell me what are the different issues that you're encountering. Now, one thing is that you need to be very specific in the way you answer questions. So make sure to use keywords. Now here, I think I said both models and it's able to correctly create two answers by looking at the previous context. The first one is the training hardware used for training DeepSeek V3, and the other one is O3 Mini. But in some cases, if you ask a question and it could be enhanced based on the previous chat, it may or may not be able to pick that, right? So it's better to be very explicit. For example, I could have used keywords like, what is the training hardware that was used for training a DeepSeek V3 and O3 Mini, right? So that increases the chances of better retrieval. It was able to correctly pick the numbers from DeepSeek V3, but for O3 Mini, it's not mentioned. Okay, one more option which I'll highly recommend is when you figure out what is the number of re-ranked or ranked chunks, then you also probably want to look at pruning. So this is helpful because when you rank chunks, not all of the text in the chunk may be actually relevant to the question, right? So the pruning will do sentence level pruning, and it will only keep the most relevant sentences rather than the whole chunk. I have created a previous video on the topic. I'm going to link it in the video description. But let me show you how to set up localGPT with this new version on your own machine. Actually, before that, there's this option, drag node triage, right? So if you pick this or toggle, this will actually force the system to always use the retrieval pipeline, right? So it's going to completely ignore the knowledge from the LLM and it will always use RAG pipeline, right? Okay, so in order to set it up, go to localGPT GitHub repo. And in here, you're going to see this localGPT v2. Now, if you have found this project useful so far, make sure to give it a star on GitHub. I'd highly appreciate that. So this is the new version of the documentation. It talks about the philosophy, different features. At the moment, it's only supporting PDF files, but support for all of the other unstructured files is coming soon. There are going to be 3 different options for you to install this. One is Docker deployment. The other one is direct deployment. And there are, I think, another one is manual component setup. So I'll just show you the easiest one right now. And in another video, we're going to walk through all of these different options. There is also detailed documentation about the different APIs. It's API first. If you want, you can build your own UI. You don't have to use the current UI, right? And everything is documented. So you will be able to easily create your own applications on top of this. Also, if you're a business and you want to deploy localGPT, there's a form at the end. You can fill it out and I'll personally help you out with it. Now, since this is not on the main branch, so we'll have to clone it from this branch. For this, you want to use this command. So essentially, this is localGPT v2 branch, and we're going to create a folder called localGPT. So let me actually just copy this and show you on my system. So I'm going to paste that command, but let's say I want to create a folder called local. Actually, what happened? Okay, I think it's supposed to be git clone in that branch. Okay, so I might have to actually fix this. Yeah, you can see, let's see, localGPT v2. Hopefully this is going to work. Okay, I'm going to fix that command. We found a bug. Okay, so then cd local. We are on the localGPT v2 branch now, and here are all the files. Now, you need to have npm installed on your local machine or Node.js, and it's one of the requirements, right? So the next step is going to be to install npm. Actually, let's create a conda environment. So let's call it local Python. You want to use 3.11 or 3.10 is going to work as well. Let's just run this. Okay, so the virtual environment is created. So we're going to just activate this. So you can see this is the virtual environment that we're using. Now we're going to install the requirements from requirements.txt. Okay, so the installation is complete. Now, another thing that I forgot to mention, it's pure Python. The dependencies are minimal. It's not using LangChain, Llama index. The whole RAG setup is actually implemented in Python itself, right? So hopefully you're not going to run into a lot of dependencies issues. Now, in order to run this, there are two ways. One is just run Python underscore system. It will start the backend server. It will start the front-end server, and you will be able to start using it right away. The other one I'm going to show you is running 3 different files, but over there, that's probably best for development purposes. So it started the different services. You will need to have Ollama running before starting this. Now, in order to access the front end, just access this on your local host. Now, the second way of running this, which I highly recommend, especially for initial development purposes, open 3 different tabs. So actually, this was a previous virtual environment that I created. Now, in the first one, you want to run backend underscore server.py. This is going to start your backend API. Then we're going to start rag underscore system.api underscore server. Okay, so this is the main rag pipeline. Okay, so this is starting it. And the last one is going to be npm run dev. Okay, so this is going to start our front end. And now we can just go to our local host on port 3000. You're going to see that everything is running. Now, sometimes with the first method, if any other session is using the same port, you might run into some issues. But with this method, usually it's able to find the backend easily. So again, we're going to just walk through the same steps of creating a new index and then start interacting with it. One more thing before we close off this video, the chunking process is really dependent on the quality of the PDF files, right? So if Dockling is not able to parse the PDF file correctly, the rest of the pipeline might run into some issues, right? So I'm actually thinking about integrating vision-based retrieval as a part of localGPT, but for that, you will need a much better GPU because you're going to be running multiple models, and the vision models usually requires a lot more resources. Okay, so this was a quick intro of the new localGPT. Play with this, install it on your local machine, and let me know what type of issues you're running into. I want to address all of those. I'm going to clean up the existing code setup. This is going to remain as a separate branch for the next couple of weeks. But once we have a stable version, this is going to replace the newer version or the older version of localGPT, and it's going to become the main branch. I'm actually excited about where this project leads us. Do let me know your feedback, and I hope you found this video useful. Thanks for watching, and as always, see you in the next one.